So now let's look at our graph of cotangent. As a refresher, cotangent is the same thing as 1 over tangent, or how we're going to think about it, where tangent is sine over cosine, cotangent is cosine over sine. So what we're going to do is go through those coordinates again. Let's see those as well, just these increments of pi over 4 to figure out what cotangent is by taking the x coordinate divided by the y coordinate. So if we're at negative pi, that would be a negative 1 over 0, which would be undefined. Can't divide by 0. At negative 3 pi over 4, that's that negative root 2 over 2 divided by negative root 2 over 2. So that's going to be equal to 1. Negative pi over 2 will be a 0 over negative 1, which is just equal to 0. Negative pi over 4 will be a root 2 over 2 divided by negative root 2 over 2. So that's going to be a negative 1. And then at 0, we'll have 1 divided by 0, which is undefined. At pi over 4, we'll have root 2 over 2 divided by root 2 over 2, so a positive 1. And then we'll kind of see that routine, 0, negative 1, undefined. All right, so if we set up our axes here, what we can see is our asymptotes land in different spots than when we were working with tangent. So now at negative pi, which is over here, and at 0, and at positive pi, and then we can just see for every 4 squares, there will be an asymptote. But something that I keep in mind with cotangent is the fact that the y-axis itself is an asymptote. So that's going to be something that we use when making our graphs. All right, and then we'll just plot some points. So we go positive 1, 0, negative 1. Oops, I didn't stretch far enough there. Positive 1, negative 1. Positive 1, 0, negative 1. So if you think in comparison to our tangent function, this one's decreasing. So it's going in a negative direction. But the shape, and again, it's kind of hard, kind of zoomed in like this, but the shape is just like tangent. It's just going in a different direction in different locations. And something like that. So the structure for cotangent looks a lot like tangent. We still have this period of pi occurring. So every 4 blocks or this distance of pi, there's going to be an asymptote. It's just our asymptotes start at 0. And then from there, just make sure the points go positive, 0, negative. All right, domain of the graph. What we're seeing here is like from 0 to pi is a single period. So the period stays the same. This first asymptote is occurring at pi. Then we can see there's another one at 2 pi. There's also one at negative pi. There's also one at negative 2 pi. So really what we can do here for our domain is just say that x cannot be any increment of pi. If we multiply pi by a number, even 0, it's going to be undefined there. So how I'm going to write that is that x is defined by that x cannot equal pi times k, where k is an integer. So if I plug in any integer for k, so 0, 1, 2, 3, 4, 5, or any negative 1, 2, 3, 4, 5, x can't be equal to that value. Now the range can be anything. So that's all real numbers. So negative infinity to infinity in interval notation, or we could say x is all real numbers. That works as well. With symmetry here, what we're going to see is if we reflect over the y-axis, we don't line up with our function, but if we reflect over the y-axis and then over the, I missed that point there. Sorry, sometimes that symmetry helps double check our work. I didn't stretch far enough there. Okay, there we go. So reflect over the y-axis, reflect over the x-axis. We have symmetry about the origin. So what that tells me is that this is an odd function, like we proved before. All right, and then as we saw up there, one period of the graph is a distance of pi. Again, we'll keep that in mind for our transformations. So the domain's a little simpler here since it's not shifted away from the y-axis, but we still have those increments. But overall, kind of general shape of tangent just moved over, and then change in direction in terms of positive to negative instead of negative to positive.